Proven filtration, future redefined. The era of alternative power, hydrogen fuel cell.
Hello, and welcome to our video series, Proven Filtration, Future Redefined. I'm Kristof Decoster, Engineering Director for Mobile Solutions at Donaldson. Today, we'll be exploring the topic of hydrogen fuel cells. Let's dive into the role of a hydrogen fuel cell in the heavy-duty and commercial vehicle space. A hydrogen fuel cell can replace your typical engine to provide power for vehicles and machines. While theoretically, all these engines could be converted to hydrogen fuel cells, in practice, the current largest demand is on all-highway trucks and buses for public transport. Now, let's elaborate on what a fuel cell is. There are different types, but the PM hydrogen fuel cell is mostly used. It facilitates an electrochemical process where hydrogen reacts with oxygen to produce electricity. Like an engine, it produces heat, but not harmful exhaust fumes. Instead, it produces water. Let's delve into the internal workings of a fuel cell. At its core, a fuel cell has a special membrane where hydrogen is presented on one side, the anode side, and oxygen, usually taken from the air, on the other side, the cathode side. Hydrogen atoms have one proton and one electron. The proton splits from the electron and migrates through the membrane to react with oxygen on the opposite side, forming water. This process is why it's called proton exchange membrane. And this membrane is supported by conductive plates that capture the electrons and feed them to the electrical circuit for powering an electromotor or charging a battery. The operation described seems straightforward, but in reality, it's more complex. You need multiple cells to generate enough power for what you would typically need for trucks and buses. Heat management with water cooling is necessary. Hydrogen needs to be safely stored and decompressed on one side, and air must be pumped and treated on the other side. So you have three main streams to manage: hydrogen, air, and coolant. And these streams indeed require filtration. The air must be free of particles and chemicals like acids and bases. The hydrogen requires a high purity level, and the coolant flows through narrow channels in electrically conductive plates. So it must be particle-free and kept non-conductive. As for the water generated within the fuel cells, part of it is reused within the system, but most will be waste. In many applications, you don't want the waste expelled on streets, equipment, or people, so it needs to be captured and disposed of in a controlled way. The humidifier reuses part of that water to humidify the incoming air through a membrane transfer. The topic of fuel cells is intricate, and we'll delve into it further in a separate video with more Donaldson experts. In the meantime, if you have any questions or would like more information, visit us at donaldson.com or scan the QR code.
Proven filtration, future redefined. The era of alternative power, hydrogen fuel cell.